All right, so we are going to start today's lesson. The objective for the first part of the lesson is to solve and graph simple inequalities that involve addition and subtraction. And we're going to start by comparing equations to inequalities because there's a lot of similarities. So on an equation, if I have x plus 2 equals 5, how do we solve that? Minus 2. So you're going to subtract 2 from both sides. And so it's going to look like this. Minus 2, we get x equals 3. Now a graph of that is not very exciting. We don't usually graph solutions to equations, but you could. What it would look like is basically you'd have a number line and there would just be a point at 3. One single dot. And usually they'll put that point on the number line. For the PowerPoint, everything's going to show up underneath the number line just to make sure you can tell where it's at. Yes?
Will this point be filled in or
it is filled in if it's equals. Yes, equals is what makes the point filled in. So we solve this inequality on the right-hand side the same way. X plus 2 is less than or equal to 5. They just took the equals out and made it less than or equal to. You still just subtract 2 from both sides. And you'll get x is less than or equal to 3. So that's your solution, but there's an infinite number of numbers that would actually make that true. So if we go over to 3, it does still have the equal to bar, so we still fill in that point. And then all of the numbers to the left would be shaded in because all of these are the numbers that are less than 3. So you have an infinite number of solutions. So this is kind of popping up at the bottom. For equations, if they're like this with just an x with no powers, we get one solution. But as soon as we put in the less than, greater than symbols, we get infinite solutions because there's an infinite number of numbers on this side of the number line that would be less than 3. There's only one point that equals 3, but there's an infinite number of points that are less than, and it's all part of that solution. Okay, so we're going to look at a lot of different things today. No, it'll start from the beginning. Okay, so I got interrupted, so I'm going to rush through the first couple. We did this yesterday. We have x is greater than or equal to negative 2. You fill in the point at negative 2 to represent the part that's equal to negative 2. And then the points that are greater than that go to the right. Number 2. We would also have a filled in point at 3 because that represents the part that is equal to 3. And then the numbers to the left represent the less than situation. Here's all the numbers less than 3. 2, 1, 0, negative 1, negative 2. If we go over to number 3, we would not fill in the point at 2 because I don't have that little bar under the less than symbol that means equal. So I would leave this as an open point. And so that's at 2, and then we do shade to the left to represent all the numbers that are less than 2. Yep. And then on number 4, open circle at negative 1, and then all of the numbers greater to that would go to the right. So this is just reviewing what we had in the last lesson on what to do with the points and the arrows. And normally you do put this right on the number line. The PowerPoint has them slightly below just so that the arrows will show up and they won't be on top of each other. It starts to kind of disappear. And when you guys are drawing your own graphs, if there's not a graph provided, you can simplify this by just putting a couple of numbers on the number line, making sure you have the number that you need. All right, so we're going to go through some that we have to solve for x first. So on number 1, to get x by itself, we would subtract 3 from both sides. And when we do that, we have negative 7 minus 3. That's basically like adding negative 7 and negative 3 together, which would give you negative 10. So x is less than negative 10. So that part works just like solving an equation. You have the solution. And then we have to graph this on a number line so that you're going to see a little bit simplified number line on these just to make it go a little faster. You wouldn't even have to put all 3 of these. If you had negative 10 and 0, I would be okay with that. I like having 0 on there. So there's not an equal to bar, so we do not fill in the circle, and it's less than. So you're going to draw an arrow going to the left. And this represents all of the numbers that would make this original inequality true. And you could do test points. I could do -11, -12, put them in for x, and add them to 3, and you would see that they would be more negative than -7, which means it would be less than. Okay, let's look at number 2. How do I get x by itself on number 2? Go ahead.
You add 6.
Add 6. So we're going to add 6 to both sides. That cancels out the -6. So we have -4 plus 6, which just gives me 2. So I have 2 is greater than or equal to x. Now this is a tricky one, because usually the symbol kind of points the direction your arrow is going to go when you graph. This one is backwards. So if you want to, you can flip-flop this. If that helps you, do it. If not, you can also use a test point like we talked about yesterday. So on the PowerPoint, it does flip it around. You do not have to. The main thing to realize if you're flipping the 2 and the x is you also have to flip the sign from greater than to less than. So for graphing this, they're going to put several points on here. You could just do 0 and 2. Would I fill in the circle at 2? Yes, we fill that in because it does have that equal to bar. And then the points that work go to the left. And if you were super confused, you can pick anything along here and try putting it back into the original equation, subtracting 6, and just seeing if that works. You can always substitute and use a test point. Is everybody ready to move on?
No.
Okay, just do this. Okay, on number 3, how would I solve for k? Go ahead.
Me?
Yeah.
Okay. So solve for k.
Yep.
Alright, then you would subtract 8.
You would subtract 8. Good. So we'll subtract 8 from both sides. If I have -5 and -8, what do I get?
-12.
-13. Close. So -13 is less than k. If it helps you, you can flip that whole thing around and make it k is greater than -13. You have to flip the whole thing. Both sides of the inequality and the inequality symbol in the middle goes from less than to greater than, if that helps you. A lot of people like that because then if I make my graph, I can put my little circle at -13, and the greater than symbol looks like the end of this arrow, and it tells you the direction. Okay, on number 4, to get rid of -3, we would add 3. And then you get p is greater than 12. So I'm going to do very simple graphs just to save us a little bit of time. On your worksheet, the graphs are provided, so you won't have to draw all of that out, which is nice. And so we will put a circle at 12, and then because it is greater than, the numbers that are greater than 12 go to the right. So the symbol does look like an arrowhead. That's actually where the less than and greater than symbols come from. But remember that you can only use that little trick if your variable's on the left. So if not, you might want to flip it or use a test point. Alrighty, so that was just using adding and subtracting. So now we're going to look at some simple ones involving multiplication and division. There's a little hiccup that happens that's different than equations that we're going to look at. So on number 1, if I was going to solve for x, what would I do?
Divide by 4.
Divide by 4. So you divide both sides by 4, and then I would just get x is less than or equal to 5. That one is totally fine, normal. And then we're just going to graph real quick. So look, here's my simple graph with just 0 and 5. Do I fill in the point at 5?
Yes.
Yes, because we have that equal to bar. So you fill it in, which means that 5 is the solution because 5 is equal to 5. And then all of the points representing the numbers less than 5 get filled in. How would I solve number 2? Do you remember?
Multiply by 3.
Multiply by 3. Good. This is x divided by 3, which means we're going to take both sides and multiply by 3. And that cancels out the divide by 3 and gets rid of the fraction, essentially. So we'll have -2 times 3 on the right-hand side. So x is greater than -6. Good. And then you just have to quickly do a little graph. So this solution that I have circled, you have to have on your paper, And then for some reason this has -6 and +6. I'm not sure why I have 3 points there, but same deal. We're going to put a circle at 6. It is not filled in because we don't have equal to 6 as part of the solution. And then we're looking for numbers greater than -6. And so we're going to shade and make our arrow to the right. So these are pretty simple. These you can solve pretty much just like equations. Where it starts getting interesting is when you multiply and divide by negatives, which is the next slide. Inequalities transform like equations except. So I'm going to show you an example. I have -3x is less than or equal to 6. The left side is negative, the right side is positive. How do I solve for x? Divide by -3. Now when you divide by a negative, what's going to happen is I'm going to get positive x on the left side and -2 on the right side. So I did have negative on the left, positive on the right, everything flipped. So what's going to happen is if you divide by a negative, you have to flip the sign. It goes from less than to greater than. And there's this little box at the bottom. If you multiply or divide by a negative number, then you must flip the inequality symbol. So that only is if you multiply or divide. And the reason is because when you multiply or divide by a negative number, it changes the signs on the numbers on both sides of the equation. It's like it's flipping where you are on the number line. Okay, so we're going to look at some of those. So on number 1 in the next slide, we're going to divide by -4. So when we divide by a -4, what's going to happen is that symbol is going to flip. I think there's a sound effect there. Did you hear it? Kind of sounds like we just flipped it around. So you can make that sound to yourself. Flip it around. And so the less than becomes the greater than when you divide by a negative. And that's because we went from having negative on the left side to having just positive x. We went from having positive 24 on the right side to having -6. So because we switched the negatives and positives around, it flips the sign. And then we just graph that really quick. I know you guys are getting tired of graphing, but you do it on all of them because there's infinite solutions and the graph just shows it really nicely. So we do not fill in the circle at -6, and this one is now greater than, which goes to the right. So if you were to forget that dividing by a negative flips that sign around, your arrow would be going the wrong way on the answer, which would be unfortunate because you would miss this problem. On number 2, when we're solving for y, we're going to multiply by -3. So multiplying by negative does the same thing. Let's listen for the sound effect. There it is. So we went from greater than or equal to less than or equal to. And so we'll have y is less than or equal to -21. And so we're not going to number all the way to -21. Who has time for that? So we're just going to make a simple graph. Do we fill in the circle on -21?
Yep.
Yes, because equal to is part of the solution. So that point lets us know -21 is part of the solution. And then our arrow goes to the left, showing all the numbers that are less than -21. Okay, moving along. Everybody ready? Okay, so on number 3, we're going to divide by 3. Do I need to flip the signs? Think about it carefully.
No,
No, why not?
because it's not a negative.
Because we're not dividing by a negative. What the number we're dividing by is +3, so we're good. There's no flipping involved. So we can just go ahead and leave it x is less than -6. If you look at the signs, we went from +3x to +x, -18, -6. Those positive-negative relationships are still basically what they were. And so that's our solution. We do the quick graph. So circle at -6, it's less than, which points to the left. On number 4, do you guys remember how to get rid of the negative and the 2 at the same time?
What?
So how would I get rid of the 2? How do I solve for m?
By -2.
Okay, so I could multiply by 2 and then I'd still have -m, or we could multiply both sides by -2. And so what it did was it basically moved this negative down in the bottom with the 2, which is legal. It's still inside the fraction. And then that way we can cancel out that -2. But now We're multiplying by negative, so let's listen for it. It's going to flip around really quick. And so it's going to change this from less than to greater than because we multiplied by that negative. Because it's changing all of the signs. It went from negative positive to positive negative if you're looking at the left and right hand side of the equation. And so then if we graph this really quick, you'll have your circle at negative 12. It's greater than, so it goes to the right. And I'm just assuming because you guys have seen like 1,000 of these graphs that it's okay to do this quickly. If you have a question, stop me. If you're watching the video, just watch it again. So let's look at multi-step inequalities. Kind of doing these all together because you've already done a lot of different kinds of equations and I know that you guys can handle this. So if I'm going to solve this, what would I do first?
You put add 5.
Add 5. Very good. We're going to add 5 to both sides. You always undo the addition and subtraction first. And then we get 2x is less than 16. What?
Divide by 2.
And divide by 2. Do I need to flip signs or anything?
No.
No, because everything's positive. It's all good. So we're going to get x is less than 8. And we can make our graph really quick with the circle at 8. And the arrow showing us the numbers that are less than 8, which would be like 7, 6, 5, 4, 3, 2, all the way off into negative infinity on the left-hand side.
That sounds awesome.
Okay. Everybody got that?
Yes.
So let's look at some more. So on number 1, we want to get rid of minus 4, so we add 4. You'll get 3x is greater than or equal to 21. Then we divide by 3. Question? I'll back up. No? Okay, so then we divide by 3, and we'll have x is greater than or equal to 7. We didn't have to flip anything. No real negatives to deal with. Do I fill in the point at 7?
Yeah.
Yes. And then it's greater than, so that arrow is going to go to the right. On number 2, what would we do first?
Multiply 2.
Not yet. We got to add 5 first, because otherwise I'd have some weird stuff going on. So we do want to add 5 first and get the fraction by itself. And then, now that we have x over 2 is less than 8, then we can multiply both sides by 2. Let me back that up because it started to go fast. So multiply both sides by 2. That cancels out the divide by 2 on the left-hand side and gives us x is less than 16. So I am not going to number all the way to 16. Do I fill in the circle at 16? No, because there's no equal to. And which way will my arrow go, left or right? To the left. So we'll have an open circle, arrow goes to the left. By the time you're done with all these, we're going to have this all down. Okay. Moving along. We are almost done. Yes. So, 2 more slides. On number 3, it's a little tricky because I have 7 minus x. I want to get that x part by itself. I have to look at that 7. It's a nice positive 7. So how do I get rid of a positive 7?
Minus 7.
Subtract 7. So it gets confusing because there's that subtraction sign afterwards, but that goes with the x. So we're going to subtract 7 from both sides. So I will have negative x is greater than negative 3. Now negative x is technically the same thing as negative 1x. So I normally think of dividing both sides by negative 1. On this PowerPoint, they choose to multiply both sides by negative 1, which I think is weird. But either way, all it's going to do is flip the signs. And we're going to flip the inequality. So you'll get positive x and positive 3. But when we do that, we're changing everything from negative to positive, and so that flips the inequality around. Instead of greater than, you're going to get less than. So normally, I would think of that as dividing both sides by negative 1, and if that's how you want to write it in your notes, you certainly can do that. Okay, so really quick, open or close circle at 3. Open, left or right? Goes to the left. So open circle to the left. On number 4, I have parentheses. What in the world do I do? Distribute. Very good. So I'm going to take 3 times x and 3 times 5. So that'll give me 3x minus 15 is less than or equal to 12. What do I do with it now?
Add 15.
Add 15 to both sides. So then I'll have 3x is less than or equal to 27. Then we divide by 3. Do I need to flip the sign on this one?
No.
No, because we're dividing by a positive 3. Everything's staying positive, so we're good. And then we just make our little graph. So, do I fill in the point at 9?
Yes.
Yes, because I have that equal to bar. And which way does the arrow go?
Right.
To the left. So there we go. All right, so are we good on 3 and 4? I think everybody's done. If you're watching the video, you can always stop and go back. So we've got 2 more. Let's take a look at number 5. So we're going to distribute a negative 3. When I distribute the negative 3 on that left-hand side, what will I get? I know it's negative 3x, but what about the other part?
Positive 4.
Positive 12, right? Because I have negative 3 times negative 4, so I'm going to get negative 3x plus 12. And it's plus because the negative 3 times negative 4 have the same signs, give us positive 12. And then these just solve like 2-step equations. So you're right, we're going to subtract 12 next. So subtract 12, I have negative 9 and negative 12. That just makes it more negative, so negative 21.
21.
So negative 3x is greater than negative 21. What do I do now?
Divided by negative 3.
And when I divide by negative 3, what's going to happen?
Sign.
Phew. It's going to switch because we're dividing by a negative. If I multiply or divide by a negative, I have to flip that greater than and make it less than. Otherwise, I'm going to have the wrong side of my point shaded in. So we do not fill in the point at 7, and we're looking at less than, so all the numbers less than 7 would be 6, 5, 4, 3, 2, 1. This arrow represents the infinite number of numbers that are less than 7. Now number 6, I've only got one of these on here, but I wanted to talk about it. I have x's on both sides. I have 4x on the left, I have negative 2x on the right-hand side.
Add 2x.
Yes, so I think the easiest thing to do would be to add 2x and get all of the x's on one side. So then we'll have 6x minus 3 is greater than or equal to 11. What would I do next?
Plus 3.
Plus 3. So I'm going to have 6x is greater than or equal to 14.
Divide by 6.
Divide by 6. And this is not going to divide evenly. So 14 over 6 is the same thing as 7/3. Or on the number line, what would be easier is if I changed it to 2 and 1/3. You're not going to have a lot of fractions on your assignment, but I'm showing you it can happen. And normally on a number line, this would go between 2 and 3. We're just making this simple. Would I fill in the point?
Yes.
Yes, because I have that equal to, and then we're looking at numbers greater than that. So you could leave it 7/3 or 2 and 1/3 if that showed up. Either one is okay.